Hello guys, welcome to Engineers Academy. We are going to solve this problem using calculator. So the problem says that determine the magnitude and direction of this given force. So we will enter this force F as a vector in the calculator, and then we will find the absolute of that vector that will give us the magnitude of this force F. So for that we have to press the mode button, and then we have to select this 8 option. So 8 is vector, so I will press 8, and then in vectors we will select vector A. So we want to store this force F in this vector A. So 1, and now this force F has 3 components, so we will again press 1, and now we will enter the components of this force F. So first is 650 equal, then minus 320 equal, and then 760 equal, and then we will press AC. So now we want to find the absolute of that vector A which we have stored. So we will press shift, and then here we have this absolute. So absolute, and again I will press shift, and then we want to use the vector option. So for vector option we have to press 5, and now we will select vector A since we have stored this force F in this vector A. So I will press 3 and the bracket close and equal. So now the magnitude of this force F is 1050 Newton. So here we can see we can find this manually by doing this calculation, taking the squares of all the components of that force F and then taking the square roots. So the sum of the squares of the components and taking the square roots gives us 1050. And using calculator we can store that force F in vector A, and then we take the absolute. So that absolute of vector A gives us the magnitude of that force F. Then to find the direction of this vector A, we can find the unit vector. So now how to find the unit vector of this given force using calculator? So the unit vector is always equal to the vector divided by its magnitude. Press AC and then let's say shift and then 5. Again we want to use the vectors option. And then again this vector A, since that force F is stored in vector A, so we will press 3 and then divided by this vector A divided by that magnitude of vector A. So vector A divided by the absolute of vector A. So shift, absolute, again shift, 5, and then vector A, 3, bracket close. So this is vector A divided by the absolute of vector A. So the absolute of vector A is the magnitude of vector A. So vector A divided by its magnitude will give us the unit vector. So equal. So this gives us the unit vector. And unit vector, we can represent this unit vectors in terms of the direction cosine. So cos of alpha, cos of beta, and cos of gamma, these are the angles. Alpha, beta, and gamma are the angles of this force F with positive x, y, and z axes respectively. So now if we compare all these components, so cos of alpha is ax divided by a, cos of beta is ay divided by a, and cos of gamma is az divided by a. And since we have determined that unit vector, so 0.619, so this cos of alpha is equal to 0.619. We can represent this alpha, beta, and gamma as theta x, theta y, and theta z angles as well. So alpha is theta x, the angle of this force F with the x-axis. Beta is the angle with the y-axis, so theta y, and this is theta z. So now since we have determined this unit vector, so we know cos of theta x, cos of theta y, and theta z from calculator. So cos of theta x from calculator is 0.61904. Similarly, cos of theta y is minus 0.30476, and similarly the cos of theta z is 0.732380, and these three numbers are known as the direction cosines. So they are cos of alpha, or cos of theta x, cos of theta y, and cos of theta z. And now if we want to find the direction of this force F, we need to find these angles theta x, theta y, and theta z. So we need to take the cos inverse of this direction cosines. So cos inverse of this will give us this angle 51.8 degrees. So let's find this. So shift cos inverse of this, so 0.619 51.904 equal, so this gives us 51.75, which is approximately equal to 51.8. And similarly, the cos inverse of this will gives us 107.7 degrees, and similarly the cos inverse of this number will give us 43.6 degrees. So again, I will repeat the procedure for this. In order to get these values, we need to find the unit vector. Since the unit vector is equal to the vector A divided by the magnitude, that will be equal to AX divided by A, AY divided by A, AZ divided by A. So this means that we need to divide this given vector by its magnitude. So that will give us the unit vector. And the components of the unit vector will be equal to cos of theta x, cos of theta y, and cos of theta z, or cos of alpha, beta, and gamma. So for that, we will press the mode and then we will select 8, and then we will store that force F in vector A. And then since this vector has 3 components, so again we will press 1. So again we will enter this force F. So 650 equal minus 320 equal 760 equal, and then press AC. And now we want to divide this force F vector by its magnitude. So shift 5 vector A 3 divided by the absolute of vector A, which is the magnitude of that force F. So shift absolute, shift 5 for vector A, press 3, bracket close, equal. So this gives us the unit vector of that force F, and this 0.619 is the component of the unit vector along the x-axis. This is the component of the unit vector along the y-axis. This is the component of the unit vector along the z-axis. And these 3 numbers are known as the direction cosines, and these 3 numbers are equal to cos of theta x. This is equal to cos of theta y. This is equal to cos of theta z. So this means that we know by dividing the vector by its magnitude, we get cos of theta x value, cos of theta y value, and cos of theta z value. So we get, instead of dividing these components by the magnitude of force F, we get directly these values, 0.61904, this number and this number. And then taking the inverse of these numbers will give us the angles of this force F with the x, y, and z axes respectively. And similarly, to confirm your answer, if we take the squares of these direction cosines, that must be equal to 1. So let's check it. So that is 0.61904 square plus minus 0.30476 square plus 0.73280 square equal. So this is approximately equal to 1.01. So it is approximately equal to 1. So this confirms that these are the direction cosines, and the sum of the squares of these direction cosines must be equal to 1. So I hope this will help you in finding the unit vector of a given Cartesian vector using calculator.